yet. So in terms of eigenvectors, you will find that like you have a vector, like let's say maybe you have a lambda. It can be in a form of this way. Let's say you can have a lambda minus 1, for example, to the power 3. So when you get a lambda minus 1 to the power 3, when you solve it, which is equals to 0, then you will find that your lambda, it have to be equals to 1, but it happens the power, the exponent there is 3. So if you have a matrix which is A, how do we really solve this? So we are going to be problems today. So I sent you a document in your WhatsApp for few questions. So if you check there, we have question exercise is exercise 3.2. So we have that one. When I send it to you, I'm just going to take any matrix there. Then we're gonna start with a simple one, which is matrix B. So in matrix B, if you check number 2, there it says for each of the following matrix, find at least one chain of length 2. So one chain of length 2. Then what do they mean when they say that? You will see now when we are doing the questions. So if we have the matrix that we have for B, I will name it as matrix A. So our matrix A is going to be 1, 1, 0, 0, 1, 0, and then we also have 0, 0, 0, 0. So in this matrix A here, we have to solve it. When we solve it, the first thing that we're going to do, we are going to get the absolute, whereby we're going to introduce the lambda. So when we get the absolute, it's going to be 1 minus lambda, and then 1 and 0, 0, 1 minus lambda again, and 0 again. Then it's going to be 0, 0, 0 minus lambda, which everything here must be equals to O, equals to 0. Then now we can solve it. Then if I use the method I've teach you already, if I take 1 minus lambda, absolutely, I'm gonna go this, I can go this way. It's going to be this way and this way. Then I'm going to be left with 1 minus lambda and 0 and 0 and minus lambda. This is minus 0 minus lambda is just the same as minus lambda. This is going to be minus here. Then absolute value, I'm just writing absolute value because here is 0. Then if I cross here, this side, and here, you will see that is 0, 0, 0, and minus lambda. It's going to be 0, 0, and again 0, and minus lambda. Then when we come to plus, here is 0, so we can ignore it. We can just say this is equals to 0. Then 1 minus lambda. If we say this times this, we will see that we're going to get lambda plus minus lambda plus lambda squared. And if we say 0 times 0 is going to be 0, then minus here is going to be 0 and 0. This is equals to 0. So if we can solve this matrix here, we can see that we have a lambda outside. We can take out lambda out. we can take out lambda. If I take out lambda here, or negative lambda, let me take out negative lambda. You will see that this matrix is going to be 1 minus lambda again. Again, here is going to be 1 minus lambda, which is equals to what? Equals to 0. Then these two here, they are the same. So which means we can write this as 1 minus lambda squared into minus lambda, which is equals to 0. So now, when we have done that, our lambda is going to be equals to 0, or our 1 minus lambda squared is going to be equals to 0. Is going to be equals to 0. So now we have two types. So this one here, it implies that 1 minus lambda is equals to 0. It implies that our lambda is going to be equals to, this one is going to go, it's going to be negative, going to be equals to 1. So when we have 1 now, we can solve this matrix. We can substitute the 1 inside here in this matrix. So when we substitute the 1 inside that matrix, we will see that our matrix is going to be in this form. So I'm just going to be solving it same time. So when we see that our matrix is going to be in this form, it's going to be 1 minus 1 is going to give us 0, 1, 0, 0, 0 is 1 minus 0, 0. Then we're going to have 0, 0, 0, 0, 1 minus, okay, there is something that I think I'm not okay. Yeah, for us here in our matrix, we used this one as 0, 0. If you check here, we use 0, 0, 0. So it's going to be 0 minus 1, which is going to be minus 1 here. It's going to be minus 1. So we're going to use the one that we used there. I didn't copy the right one in the exercise there. So now when we have this is also, we can say, using gaseous elimination quickly, we can say this is going to be equals to 0, 0, 0. Then we will be able to see that in this one here, we have negative, if it's U1, U2, or V, let's use V1, V2, V3. So you will see that V3 equals to what? Equals to 0, and V2 also equals to 0. So it's not going to be, it's not going to work for us properly, because every time when we want to work it out, it's going to give us 0, 0. So let me just pick up another one so that you can see the purpose of this chapter, why when it says that. So I made a mistake by not putting one there. So, but we can put, there is another one, which is number A there. I will try to copy exactly what is written there so that we don't have a problem. So we have this matrix here. This one we can do the same way, the way we did before. So here it's going to be equals to 0, then, oh, sorry, I forgot the 1 there, minus this one here is gonna be 0, 0, 1, and minus 2, minus lambda, but it's still going to be give us 0, it's fine. So when we work it out, it's gonna be 1 minus lambda. This one times this one is gonna be 1 minus lambda. And minus 2 minus lambda. This one is gonna be 0. Then this is going to be, here also is going to be 0. We're gonna say it's equals to 0. Then when we multiply here, you will see we have 1 minus lambda. We can make it squared because we have 1 minus lambda squared there over minus 2 minus lambda. So our focus here, it will be in this one here for the one with a square. So the answer here, we're gonna see that our lambda is going to be equals to 1. So when our lambda equals to 1, we can substitute it back to our equation. When we substitute it back, we want to solve for lambda first. When we substitute it back, it will give us 0. 1 minus 1 is going to be 0, 1, and 0 again, 0, 0, 0. Then it's going to be 1, 2. Minus 2 minus 1 is going to be minus 3 over 0, 0, 0. So we can exchange row 2 and row 3. Then this will give us this way. Gonna be, or we can change this one. Row 3 is gonna be 1. Row 3 and we can change row 3. It will be 1, 2, and minus 3. We can write it on top, 0. Then we can write this one 0, 1, 0, 0 there. Then 0, 0, 0. We can write it this side. So maybe if you want, we can say if we want to do something, let's say, for example, we want to subtract 1 here, we can still do that, or we can leave it as it is. When we are working with V1 and V2 and V3, then our V1 plus 2 V2 plus minus 3 V3 is going to be equals to 0. But we have already a V2. That V2 equals to what? Equals to 0. So when V2 equals to 0, we can substitute V2 here. Then we will have V1 plus, or we can just say we know that this one is going to be 0. Then we will have V1 minus 3 V3 equals to what? Equals to 0. Then which means our V1, this implies that our V1 is going to be equals to 3 V3. So now if we let V3 equals to 1, then we know that our V1 is going to be equals to 3. So we will have a matrix. I will write it in terms of transpose. Our V1 is going to be 3, and our V2, it was 0, and our V3, it was 1. So this one is in form of a transpose matrix. So now we have found this because of it's 2 there, because we got that this matrix here is 2. On top here, we can now use this one we got, which is 3, 0, and 1, to find the other one. So when we do that, I will try to, let me erase some few part here. So now what we're gonna do, in the same matrix that we used, when we substitute lambda in this matrix, we got that this matrix is this. So what we're going to do, we're gonna copy the same matrix. Let me also delete here. We will copy the same matrix, which is 2. No, it was 1, if I'm not mistaken. Let me check it first. The first is 1, 2, 3. 1, 2. 1, 2, and -3. Given, we're gonna write it. Then let's check the other one. I think it was 0, 1, 0, and the other one was 0, 0, 0. So now we are going to use, instead of 0, 0, the second time we use this one now, 3, 0, and 1. So we're going to use 3, 0, and 1. So now when we use 3, 0, and 1, you will see that in our matrix again, if we rewrite it, it's going to say V1 plus 2V2 minus 3V3 is equals to 3. So if we have if our V2 based on this solution here is still equals to 0, then it means that our V1, if we substitute 0 here, we're going to have V1 minus 3V3 equals to 3. So if we let V1, if we let V3 equals to 1, then our V1 now is going to give us to minus 3 in brackets 1, which is equals to 3. Then our V1 is going to be equals to 3. This one, because it's negative, when it goes to the other side, it's going to be plus 3, which is going to be equals to 6. So now the new one we have is going to be, this is the chain of the length to vector space. It's a vector space, by the way, an eigenvector. So we found that V1 is 3, 6, and then V2 was 0, and then V3 was 1. I'm writing them, when I say I'm writing in transport, it's the same as I can write them this way: 6, 0, and 1. So now the chain of length through, we have just found how we get it. The first one was this one, then the second one is this one. Then we are done. So that's how you normally do based in this programming. Sorry, based in this mathematics. So do you have any question?
No.
All right. So which means you can also try maybe to do some other exercises there. So maybe we can also go to a book. So this exercise, for each, find the least one share of length 3. Maybe we can do, there's others whereby for length 3, let's try to do, I'm gonna just do one in this exercise. Then we're gonna open also a question paper. We do the similar question with this one for MAT 13706. So let's A equals to, I'm using number 3. when the length is 3, I'm going to use number B. So the matrix that we're going to work with, 0, 1, so let's say we have this matrix. Then when we have this matrix here, we can first do the same process. We found the lambda. So in this one here, if we want to see that minus lambda again, 1 minus 3, and 3 minus lambda minus 1. If we use this one here, it's going to be 0 and 1, 0 and 1, 1 and 3 minus lambda. And then here, because it's 0, we can just say this is equals to 0. Then minus lambda here is going to be this times this is going to be minus lambda 3 minus lambda plus 3. This times this is going to be 1, then minus 1 here. Also, it's going to be 1, 0 minus 1, which is equals to 0. So if we check here, we're going to have plus 1. Then we can say this is going to be the same as minus lambda if we do it perfectly. Minus 3 lambda plus lambda squared plus 3 plus 1 has to 0. Then three lambda squared minus lambda cubic plus plus 1 is going to be equals to 0. Then we can factorize. So I think you said you have a calculator to factorize this, ne?
Yes.
Can you maybe do it for me quickly so that we can speed up a little bit? Because I'm gonna use a long division for me to.
It just says x is equal to 1.
Only x equals to 1, ne? Like this way, which means lambda equals to 1. Let's assume that it means that lambda equals to 1. So if you check here, if lambda equals to 1, you will see that if I put 1 here, let's put it must give us 0 just to verify. It's going to be 3 minus 3, and this one 3 is going to be 1, yes. So now it's fine. So this means that here it's going to be lambda minus 1, like this way, cubic equals to 0. So if we use lambda minus 1 cubic, it's going to give you exactly, it's going to give you exactly this matrix that we have here. So whatever that you're going to do, it will take you there exactly. So we're going to have lambda minus 1 equals cubic equals to 0. Then we're going to go back when lambda equals to 1. We substitute it in this matrix there. So when we substitute the first one, it's going to give us 0 minus lambda is going to be 0 minus lambda is going to be minus 1. Going to be minus 1, 1 and 0. Everything here is going to be 0 the first time. Then 0 and 0 minus lambda is going to be minus 1, which means it's going to be 0, minus 1 and 1. Again, here it's going to be 0. Then 1 minus 3, 3 minus 1. Let me check. Are you the one? 1 minus 3. Okay. And then 1 minus 3. 1 minus 3 is going to be minus 3. 3 minus 1 is going to be 2 and 0. So if we have this, you will see that, okay, we can try to solve it. This one plus this one, this implies that we can first, this one plus this one is we can leave this one the way it is there. 1 minus 1 and 0, 0. Okay, 0 minus 1. Let me leave it as it is. This one plus this one is going to be 0. This one plus this one is going to be minus 2. 0 plus 2 is going to be 2 and 0 there. So you can see here we can divide by 2. If we divide by negative 2 everything here we're going to have positive 1. We're going to have positive 1 here. And then here we're going to have negative 1 if we divide by 2. So now we will add this one. I'm going to say 0 minus 1 and 1 is fine. Then we'll add this to 0 plus 0 is going to be 0. This one plus this one is going to be 0. This one plus this one also is going to give us 0, 0, 0. So now we have a matrix. We can rewrite this as negative V1 plus V2 equals to 0. Then this implies that negative 1 equals to negative V1, V2, then V1 is going to be equals to V2. Then we also have this one here, negative V2 is going to be equals to negative V. We can just say plus negative 1 of V3. So now if we let V3, if we let one of this, let's say V3, if you let V3 equals to 1, then which means your V2 is going to be equals to 1 also. And when your V2 equals to 1, it also implies that your V1 equals to what? 1. When we substitute 1 there, everything is 1. So we have this vector, eigenvector, 1, 1, 1. So now we are going to use this 1, 1, 1 the second time. This one is for length 3. So when we use it the second time, I will just erase, it was matrix of 1, 1. I will erase this part here. I will erase this part. When I erase that part, I'm going to substitute. It's still the same. We're using a matrix of length 1. Then we're going to have again, will be negative 1, 1, and 0, 0, negative 1, and 1, 1, negative 3. 3 minus 1 is going to be 2. Given now, instead of 0, we use 1, 1, and 1. So we can now solve this matrix. So when we solve this matrix here, you will see that we can still do the same. Let me just solve it this side first. For in case of the space, negative 1, 1, and 0, and 1. Then we can use this one plus that one. This one we can leave as it is for now. 0, negative 1, and 1, and 1 there. We're going to get 0. This one plus this one is still going to give us minus 2. This one plus this one here is 2. It's going to give us 2 again. And then this one plus this one is going to give us 2. So I can divide everything by 2 here. If I divide by negative 2, you will see that here I'm going to have 1. And if I divide by negative 2, here I'm going to have negative 1. And divide by negative 2 here, I'm going to have negative 1 again. So now, negative 1, 1, and 0, and 1, 0, negative 1, and 1, and 1. So we're gonna add this plus this is gonna give us 0, minus 1 plus 1 is gonna give us 0, 1 minus 1 is gonna give us 0. This one also 1 plus this one again is gonna give us 0. So now we have a negative V1. Negative 1 is going to be equals to negative V2. So we can just say plus negative, we can just say V1. We can just write it as V1 equals to V2. So when we write it as V1 equals to V2, then here also negative V1, negative V2, this is negative V2, is plus V3 is going to be equals to 1. So when we add plus V3 equals to 1, we will see that if we let our if we let V3 equals to 1, we can see that minus V2 is going to be equals to 1 minus, this is going to be minus 1 minus what? Minus V3, which is 1 minus 1 is going to give us 0. Then this implies that V2 equals to what? We can say V2 equals to 0, which means if V2 equals to 0, according to this equation, our V1 also is going to be equals to what? 0. So now we have an eigenvector of V1 is going to be 0, V2 0, and V3 is 1 in a transpose. So now we have 0, 0, 1. Then we have to again, I'm just going to delete few things. We will have to again, in this same matrix here, we are going to use this one 0, 0, 1. We are no longer going to use 1, 1. So when we use 0, 0, 1, 0, 0, 1. So when we use 0, 0, 1, you will see that in this matrix here, if we say 0, even here is supposed to be, let me erase here 0, 0, 1. Gonna be 1, 0. So if this one here we haven't done anything, it's gonna be 0 again. Then If we say this one plus this one is going to be 0, this one plus this one plus this one is going to be -2. And then this one plus this one is going to be 2. And then 0 plus 1 is going to be 1. So if we divide, here it was 2, -2 and 2. If we divide everything by -2, we're going to have 0, 1, -1, and 1, negative. We're going to have -1/2 here. When we have -1/2 like this, I'm going to erase this part here. We have this kind of matrix. We can add this 0 plus this one is going to give us 0. This one plus this one is going to give us 0. This one plus this one is going to give us 0. 0 plus this one is going to give us -1/2, which we can just write 0, 0, -1/2. So now, when we have this, now because this is non-trivial, we can focus on this one here. So when we focus on these two, you will see that now the new matrix that we're going to have is going to have -V2. Here is going to be -V1 equals to V1 is going to be equals to V2. And then this side also -V1 is going to be equals to -V3. V2, not V1, V2 is going to be equals to V3. So if we let V3 equals to 1, everything here is going to be 1. So we're going to have 1, 1, 1 of t. So, and we already achieve also this one. So sometimes when you do it in some other matrix, you will find that you are not getting the same. But the point is that you get this one, you get this one. Even the first time, I think we got this one, which is similar to this one. So the ones that you can write, you write them like this is fine. But this is two, those two, they are the similar ones. So you can only write one. But when they say the length of 3, they mean that you must do it 3 times. After when we use this one, we got this value. We got this eigenvector. After we use this eigenvector, then we go back to this one again, which is the same as the first one. So this is the procedure. This is the procedure of how we do it. So let's try to check some question paper. Maybe we can get one example, but this one normally when you work it out, it's going to be in the form of maybe a question. It won't really ask straightforward this way, but that's how you will apply it maybe in any question. Yeah. So I'm just gonna check if in one of the questions here we have this kind of question. So the first one here, determine whether the system has no solution. We've done that before, even this one. Define the define the concept of a root vector. Okay, it's fine. You have this one here. Let's check this one. Okay, is if Q is a fundamental matrix of if F, okay, is not the same. Yeah, I think use the power series method to find a series solution of, you have this one here, 1, 1, 1, 1. You have given X. It's not the same as the one. Your answer is approx. Okay, it's not really the same. Find the class factor. Okay, so I think this one here, if you check the memo, they will be asking it indirect, but this question paper is for 2024, 2014, it's quite a while. So maybe we need an advanced question paper for 2022. So if we check, I'm just trying to check the memo somewhere. So if we check here, this one, they are getting 1. Yeah, this question paper does not have what we are doing now. So maybe let's try to check. I'm not sure if I have question paper for 2022. So let me check something in my. So this one here, normally what we did today, we did chapter 5.
I can send you the recent papers, but there's no memos.
Okay, no problem. But I think, I'm not sure, I was just checking the question paper that you have sent before in my WhatsApp. So just give me a few minutes. I think maybe we do have one of.
I have 2015 with the memo.
Okay. And then maybe, don't you have 2022? Or
I can get that, but there's no memo.
yeah, I just want to check if they ask direct that the things that we are doing today. You can also send it. Okay, I got the one for 2018. So the one for 2018 is just a memo. This one, okay, it's fine. I even have a memo 2018. So for 2018, yes. So if you go to question paper for 2018, do you see a question? Do you have it for 2018?
I can get it.
Okay, or you want send it to me. You can check it 2018. So question number 5.
Which month?
Let me check. Is 2018. Let me check. This one here is just like it says tutorial letter 02/01/2018. So if you check, you will see a question there you will see a question. It's like a memo, but question number 5 is exactly the same way we are doing this one. Question 5. Let me see if I can share with you now. Yeah, I just send it to you.